Consider the circuit on your screen. The power supply V plus has a DC value of 10 volts on which is superimposed a 60 Hz sinusoid of 1 volt peak amplitude. This signal component of the power supply voltage is an imperfection in the power supply design. It is known as the power supply ripple. We'll study more about this later. Now what you have to do is that you have to calculate the incremental resistance RD, which is also the diode small signal resistance, and find the amplitude of the sine wave signal appearing across the diode. The diode has a 0.7 volt drop at 1 milliampere current and N equals 2. Okay, let's solve this. Considering DC quantities only, we assume VD to be almost equal to 0.7 volts. Remember, this is the DC quantity and not this one. So we write our first equation and we get the value of ID, that is the diode current at DC, to be 0.93 milliamperes. Now remember that we are currently now only looking at DC values. Also notice that this value 0.93 milliamperes is very close to this value 1 milliampere at which the diode is rated. Therefore, our assumption that VD, that is the diode voltage at DC, is correct. Okay, so now we find the incremental resistance RD. This comes out to be 53.8 ohms. Also notice that this RD is different from this RD with a capital D that we had studied in the piecewise linear model. Why? Because this RD over here is the small signal resistance, while here in this RD with the capital D there is no small signal approximation. Moving on, now we have to find the amplitude of the ripple at the output. For that we have to employ the small signal model. The figure at the bottom of your screen is the small signal interpretation of the circuit, which is also including the small signal model of the diode, that is this resistance RD. Our job is to find this voltage VD. We have come to this circuit by shorting the DC supply and applying the small signal input to the small signal of the diode, that is this resistance RD. So we apply a simple voltage divider where we employ the peak value of the input signal, and this comes out to be 5.35 millivolts. This value is quite small, and so our use of the small signal model of the diode is justified. Try this example for yourself.